In the May 2012 paper 2, problem number 4, we are given a scenario with an amphitheater that's got 20 rows. And we know that we have an arithmetic sequence because they tell us that each row increases with a fixed amount. And they give us information about 2 of the rows. They tell us that the 6th row has 100 seats, and they tell us that the 10th row has 124 seats, and we're asked to write equations for both of those. So we need to remember that the general term u sub n is equal to the first term, that's u sub 1, plus n minus 1 times the common difference. And so we're going to plug in what we know. We know that the 6th row is 100 plus, 100 is equal to the first term, so that's u sub 1, plus n minus 1. Well, that's the 6th row, so 6 minus 1, I'll go ahead and type that up. 6 minus 1, we know that's going to be 5 times the common difference. So we can see that we're getting ourselves set up for a system of equation. The 10th row is 124, and that's equal to u sub 1 plus n minus 1. So that's the 10th row. N minus 1 will be 9, but I'll go ahead and write that so you can see what it is. 10 minus 1 times the common difference. So now we've got 2 equations. 100 is equal to u sub 1 plus 5d, and 124 is equal to u sub 1 plus 9d. Now, we've set up a system of equations, and in this situation, it's always going to be best to solve this system of equations using subtraction. In fact, you know what I'm going to do? I'm going to go ahead, because I like to avoid working with negative numbers, I'm going to go ahead and move the second equation up to the top of the first one. And so now when I subtract 124 minus 100, I've got 24 is equal to the u sub 1's cancel out, and I've got 4d. So d is equal to 6. So the common difference is equal to 6. Now let's see. I kind of got sidetracked from the problem and just started working away. We wrote down our 2 equations. We found the value of d. Now we need to find the value of u sub 1. So we're just going to plug back into one of the equations. It doesn't matter which one. And we can solve for u sub 1. So we know that u sub 1 is equal to 70. So there's 70 seats in the first row, and then there's 20 rows altogether, and each successive row goes up by 6. That was the common difference, was 6. Okay, then in part C, we are asked to find the sum, the total number of seats. So we need to remember the formula for the sum of an arithmetic sequence, and that formula is on your formula sheet. The sum of so we're going to do the sum of the first 20 rows. Well, that's all of them. There are only 20. Is equal to, how many rows do we have? We have 20 rows. So we take, that's the total number, 20. That's n divided by 2. Always divided by 2. That's just the way the formula is. So it's kind of like the average of the first term and the last term. So we're going to take, depending on which version of the formula you use, we've got 2 times 70, because we end up with 2 u sub 1's, if you'll remember, plus n minus 1. So that's 20 minus 1, or 19, however you want to write it. 20 minus 1 times 6. So you get full method points as long as IB can see your formula with the correct values plugged in. So that sum value is equal to 2,540. And that's seats. That's how many seats there are in total. All right, now in part D it says, oh look, it must be BCC. They're grown out of their skins and they're going to have a second level, or in our case, we're going to, what are we going to add? More learning cottages. So we add our second level to increase the amphitheater's capacity by 1,600. So we know the total amount that we want to add, and we know the common difference, and we know what u sub 1 is, and we have to figure out how many rows we're going to add in so that we can find this part. Okay, so we're in part D, and let's think about what it is we have, what information we have, and what it is we're solving for. We know that the total number of seats that we're going to add is 1,600. And so that's going to be the sum of a sequence, and what we don't know is the number of rows. So that's the n value. That's what we don't know. So our formula is n divided by 2 times 2 times u sub 1. Well, they tell us in the problem that we're going to have 70 seats in the first row. So we know that u sub 1 is 70 plus n minus 1. And we don't know what n is, so we're just going to leave that as n minus 1 times 4. Where did the 4 come from? The 4 was the common difference given to us in the problem. All right, how are we going to solve this thing? So 1,600 is equal to n over 2. I should put an equal sign there. Oh dear, that looks really messy, doesn't it? 1,600 is equal to n divided by 2 times, let's see what we got. We've got 140 plus, now let's distribute, 4n minus 4. All right, now there's a couple ways that we could solve this problem. Since each, well, let's do this. Let's take 1,600 is equal to, in fact, you know what, let's do this. Let's go ahead, where's my eraser? Let's go ahead and get rid of that fraction. That 2 is bugging me. Multiply both sides of the equation by 2. So over here on the left, we're going to have 3,200. I've gotten rid of the 2, and I've got n equals n times 140 minus 4 is 136. So I've got 4n plus 136. That's 140 minus 4. All right, so I've got 3,200 is equal to 4n squared plus 136n. All right, now what do we have? Mr. Foster calls this quack quack. It looks like a quadratic, sounds like a quadratic, it's probably a quadratic. So we can go ahead and solve this now. We've got 0, set everything equal to 0, is equal to 4n squared plus 136n minus 3,200. At this point, you have several options. Well, okay, you don't have several options. You have a couple options. You can divide through by 4 and factor, or you can use the quadratic formula. And it doesn't matter how you solve the equation. When you get finished, you're going to end up with n equals 16 and n equals negative 50. Now, let's think about those two answers. What is n? Does n represent? N represents the number of rows. So we want to make sure that if our working shows when it should show the -50, we want to get rid of that as a possible solution because we can only have a positive number of rows. We couldn't have a negative number of rows for our number of seats. All right, this problem has a part A and a part B. I'm going to continue part B in another video.